Hello guys, welcome to this chemistry lesson. First of all, we are going to revise the work which I gave you. Some of you submitted your work for marking to my inbox and I had to check your work, which is good, but most of you did not do anything. Okay, so this is how guys you should have answered this question here. So let me go for solutions. Okay, so we'll start with question 1, which says calculate the number of moles in 8.4 moles of hydrogen gas. So what are they asking? Calculate the number of atoms in 8.4 moles of hydrogen gas. So they're asking to find the number of atoms, which is represented by x. So x is a question mark. In what? In 8.4 moles. So number of moles, n, we are given it is 8.4 more. We can even put like this. Now, since we are being asked to find the number of atoms, so use this formula here. Number of atoms is equal to x over Na. Okay, we already know what Na is. Na is equal to 6.022 times 10 to the power 23. So this time it is going to be, since we are being asked to find the atoms, we'll say atoms per mole. Then we'll substitute here, we'll say equals, where there's we'll actually make first this one the subject of the formula x. So if you make x the subject of the formula, it will be x is equal to n times Na. Then we'll substitute where there is n, I mean we'll put 8.4, okay, like that, more. Then you say times. Then where there is this Avogadro's number, you put this 6.0222 times 10 to the power 23. You say atoms, okay, then you say per mole. Okay, then after you do that, what you're going to do is to do the multiplication. So let me just get my calculator so that I do some multiplication here. Okay, so this is the calculator which we are going to use. So what we are going to do here is to punch in. So it's best you put this in brackets as you punch on your calculator. This one in brackets, even this one in brackets. Then you say now, open brackets, then you have like 8.4 times okay, you put in brackets first. Okay, so you have open brackets 8.4, then you close brackets, then you say times open brackets, then you say 6.022 times 10 to the power, that one there 23, then you close, then you say equals, then you see the answer there on the screen. It is 5.058, then you have 4 8, then here this more and this more here will cancel, so you remain with the atoms. Oh sorry, there's something still missing here. You have seen something here, so there is this one here times 10 to the power 24. So you say times 10 to the power 24, then you put the atoms. Okay, then since your question here, you see this value has how many decimal points after the point? It has 1. So even here it should be 1. You should end here. So you write like 5. Let me get a wrapper here and then say equals. Okay, should be 5. Then I say point. Now here I'll get the 1 from 5 at here to be 1. Then I'll come to times. Okay, then 10 to the power 24, I'll put the atoms. Okay, as the answer here. Okay, you see, this is how it is done. Then we'll come to the second question, question 2 here. Okay, so question 2 says find the number of moles in 12.022 times 10 to the power 23 molecules of ammonia. So they are asking to find what number of moles. So they are asking n is equal to question mark in 12.022 times 10 to the power molecules. So they've given us molecules represent x. So they've given us 12.022 times 10 to the power 23 molecules. So we'll get the formula. So the formula will be N is equal to X, okay, over Na. Okay. Then what we are going to do here is to substitute. So say equals. So where there is X, we'll put this one 12.022 times 10 to the power 23 molecules. Okay. Then we'll say over where there's Avogadro's constant. Remember Avogadro's constant now here, it is going to be 6.022 times 10 to the power 23. Now it will be molecules. So it will be molecules per mole. Okay, so you put it down here. You're going to put it down here. You say divided by 6.022 times 10 to the power 23. Then you say molecules, okay, molecules per mole. So this mole and this mole will cancel. Then you should divide now this into that. So to divide, you put first this in brackets and also this in brackets nicely like that. Then let me get my calculator here. So what you are going to do now, it is to get open brackets. So you say 12.022 times 10 to the power 23. You close brackets, then say divided by open brackets. You have seen the one I'm doing 6.022 times 10 to the power 23. You close brackets like that. Then you say equals. You see the answer here. It is equal to. It's giving us the answer is equal to 1.9963. Then we have 4, 6, then 7, 2, 8, then 6, 6. Then we'll remain with more like that. Now check. Since our value here had how many numbers after the point? 3. So you have to also make sure that it is the same. So you write 1 point here, 1, 2, 3. You end here, you have 9, 9, 6, because you can't get a 1 from 3 to put to 6. So it will remain like that. Then you put more like that as the answer. So this is how you are supposed to answer this question. Now, let me go now to the next part of this more concept here. So the next part of more concept we are going to look at is what we call relative formula mass. Okay, which is represented by RFM. Okay, so you need first of all to define this one. So what is relative formula mass? You can say relative, okay, relative formula mass is the sum of all the relative atomic masses of atoms in a compound, or in an ionic compound, actually, in an ionic compound. Okay, this is what relative formula mass. So it is the sum of what? Of or relative atomic masses. So meaning in relative formula mass, you add all the relative atomic masses of the elements or atoms in a compound. So relative formula mass is for what we call ionic compounds. So now let me show how to find the relative formula mass, but before I do that, you must know that relative formula mass has no units. Okay, has no units. That's what you should do. No. Now let me give you examples to show how to find the relative formula mass. Examples. So the question can be like here, like find the relative formula masses of the following ionic compounds. Then A, we have aluminium nitrate, like this. Then B, you have ammonium sulfate, like this. Then what is here too, then S4. Then you have calcium sulfate also. You can have calcium sulfate C, like Ca, then SO4. Then we can have also aluminium sulfate D. Okay, aluminium sulfate like this. Okay, these two here. Then open brackets SO4, close brackets 3. Okay, so these are enough examples on finding formula masses. So the question says find the relative formula masses of the following ionic compounds. So solutions will go like this. So for A, we have been given this compound here. This is the compound aluminium nitrate. Okay, so for you to answer this question, you must know the definition. Relative formula mass is the sum of the relative atomic masses of atoms in an ionic compound. So meaning you need to identify the atoms in this compound. So we have aluminium nitrate. So in this compound, there's aluminium atom, nitrogen atom, oxygen atom. Then you need to sum up the relative atomic masses of each of these here. So like on the periodic table, let me just show you the periodic table. So let me see if I can have the periodic table here. The periodic table. Okay, so periodic table. Okay, let me do like this. Where is it hiding now? Periodic table. Okay, here it is. This is the periodic table. So that you learn what is going on. So the periodic table is where you find the relative atomic masses of these atoms. Okay, so let me just move here. So you see aluminium is here. This is aluminium. So aluminium has a symbol there, Al, aluminium, which is aluminium here, the full name, meaning the symbol is Al. Then down here, this is the atomic number. Down here, this is the relative atomic mass. So this is the number you get for aluminium. So aluminium, you come here, you indicate that its relative atomic mass is 27. Then also for nitrogen, you come here, you see that nitrogen is here. Nitrogen, its relative atomic mass is 14 here. So you come, you put in 14 here. You also come to oxygen. You come, oxygen is here. The symbol is O. Its relative atomic mass is 16. So you get 16, you put here. Then you put the sum meaning you add them. So how you add, you say equals, okay? So you say equals, then you pick here aluminium, you say 27. Now, since there is no number down here, it means aluminium is just one atom. So you move, you say plus as you come to nitrogen. The nitrogen is 14, you put 14 there. Then because nitrogen is inside the brackets and outside there is a number 3 there, it means there are 3 atoms of aluminium, so I mean nitrogen, so you multiply by 3, okay, then you say plus, then you get for oxygen 16, so 16 here, okay. Now you see that down oxygen there's a 3, meaning there are 3 atoms of oxygen, so you need to multiply this 16 times 3, so you multiply by 3 like that. Then because there's also a 3 outside here, you also multiply by 3 again like that. Okay, so if you want, you can put these in brackets and then evaluate this at once using your calculator, because in science we use calculators to enable us to do our work faster. Okay, so what you do, just put this one, everything there. So you said like 27 plus, you see here, I'll just say open brackets, I'll just say 14 times what? 3 there, I'll close brackets, then I'll say plus, open brackets, I'll get here 16 times what? 3 times 3, then I'll close the brackets, then I'll say equals. You see, it is giving me something like let me see, 213, yeah. So meaning the answer is 213. So here you write 213 because that's what we have done. 27 there, then plus, then 14 times 3 there, then plus, then 16 times 3, then times 3, 213. So this is the relative formula mass of aluminium. It has no units, you leave it like that. Okay, then you come to B. We have ammonium sulfate, which is like this. Okay, like that, ammonium sulfate, then SO4. Then here, if you check from the periodic table, this is nitrogen, the relative atomic mass is 14. This is hydrogen, the relative atomic mass is 1. This is sulfur, the relative atomic mass is 32. Where I was picking this is where you pick this. This is oxygen, the relative atomic mass is 16. Then you start summing them up. You say 14 there. Because this nitrogen outside there's a 2, you say times 2, then plus. Then you come to hydrogen here, it has 1, you say 1. Because of this 4 here, you say times 4. Because of this 2 outside it, you say times 2 there. Okay, then you shift, you come to plus. Okay, sulfur here it is 32, so you write 32, then plus, then oxygen here 16, but there's a 4 down here, so you say 16 times 4. So now if you want, you can put these in brackets on your calculator so that you do it so quick. So you get your calculator like that, then you enter these values. So you say open brackets, you say 14 times 2, close brackets, then you say plus, open brackets, you have 1 times 4 times 2, close brackets, then say open brackets, then you also say 32. Oh, this one is alone like this. This one doesn't need to be in brackets, this one here. So here you have actually 32, which is for sulfur here. Then this is the one which is in brackets. So there you just do like you say 32, then plus, then you say open brackets, then you have 16 times what? Times 4, close brackets like that. So 14 times 2 plus 1 times 4 times 2 close brackets plus 32 there plus 16 times 4, then say equals, then you find that your answer will be 132. So equals 132 as your answer there. Then you shift to this other one. So this is AB, then C, we can answer C from here. So C, we have calcium sulfate. Okay, so calcium on the periodic table, the relative atomic mass is actually 40 here. Then sulfur is 32, as I've told you, oxygen 16. Then you sum them up, you say calcium 40, so 40, because there's nothing down here, you leave it as it is, then say plus, you come to sulfur 32, you write 32 plus, then you come to oxygen 16, because there's a 4 here, you say 16 times 4. So this is like that. Then again you get your calculator, you do the same quickly, you say 40 plus 32 plus, then open brackets 16 times what, 4, you close brackets, then you say equals, you find that it is 136, so you say equals 136 as your answer without putting units. Then we come to D. We have aluminium sulfate here. So let me just push this one a little bit down here. So we have aluminium sulfate D. So you write D here. So aluminium sulfate, which is Al, like 2 here, open brackets, AC 4, then you close 3 here. So aluminium, it is 27, its relative atomic mass, sulfur 32, oxygen 16. So again you say equals, I'll do it from here, equals, you say 27, because there's a 2 here, say times 2, then plus sulfur, because there's a 3 here, you say 32 times 3, then plus here oxygen, you say 16, because there's a 4 here times 4, then because there's a 3 here times 3, these 3 outside the brackets, then this one you can put them in brackets like that. Then you begin evaluating on your calculator. So you can say open brackets 27 times 2 close brackets, then plus open brackets 32 plus times 3, you close the brackets, then you say plus open brackets, then you have 16 times 4 times 3, you close the bracket. So let me say 27 times 2, 32 times 3, 16 times 4 times 3, yeah. Then you say equals, you see it is equal to 342 grams. So this will be the answer. Then another concept we use, relative formula mass. For ionic compound, it is called relative formula mass. But for ionic compounds, we call it relative molecular mass. Okay, so we can look at now relative molecular mass, which is written as R, then M. Oh yeah, relative molecular mass. So the definition are the same, but it differs for which it stands for. So like relative molecular mass, we define it as follows. So we say relative molecular mass. Okay, this is not as it is molecular. Molecular mass is the sum of all the relative atomic masses of atoms in a molecular compound, or you can say covalent compound. Yeah, so that's what it means. So you see the definition quite from here, it is okay. Relative molecular mass is the sum of or the relative atomic masses of atoms. Now here it says in a molecular compound or covalent compound. So this molecular compound or covalent compound are compound which are formed from covalent bonding. So the definition, they look similar all in all, and the process of finding them there is just the same, but for what they stand for is what differs. So relative molecular mass is for molecular compound or covalent compounds. It has also no units. Okay, so it has no units. Now let's look at the examples. Okay, so this example says, let me first put it in this. So can you just say determine the relative molecular masses of the following compounds. So so A, we have this one here, NH3. Then B, we have C2H4. Then C, we can have something like CH3COOH. Okay, so these are molecular compounds which I've given here. Now let's go quickly to solutions. So the process is just the same. So like A, we are looking for the relative molecular mass of NH3. This is ammonia. It is a molecular compound or a covalent compound. So we will also do the same. We'll determine the relative atomic mass for each atom. Here we have nitrogen and hydrogen atom. Nitrogen, its relative formula mass is, atomic mass is 14, hydrogen 1. Then we will sum them up. We'll say 14 here plus this one, okay, times 3. Then we'll have, so here it will be equal to here 1 times 3, it will be 3 plus 14, it will be 17. So this will be the relative atomic mass, relative molecular mass of this. Then if we go to B, we have C2H4. So what we are going to do for carbon, this is carbon. On the periodic table, its relative atomic mass is 12, hydrogen it's 1. So we'll also do the same here, 12, because there's a 2 here, we'll say 12 times 2, then plus, we'll get here hydrogen 1, because there's a 4 here, times 4, then we'll say equals. So here you see it will be like 24, because 12 times 2, it will be like 24, plus 1 times C4, it will be like 4. So if you sum this one up, it will be like 28 as the relative formula mass of this ethene. Then we got to C here. C here is ethanoic acid, which is CH3COOH. So here For carbon, it is this is carbon. Its relative atomic mass is 12. Hydrogen 1. Here carbon again 12. Here oxygen, there are two of them, 16, 16. Here hydrogen 1. So again we'll sum them up. So here we have we have 9 carbon here and carbon here. So we'll write just 12 times 2 because there are two of them. Then plus hydrogen, we have 3 here and there, so there are 4. So just say 1 times 4. Then plus oxygen, because there are 2 here, so say 16 times 2 here. Okay, then we'll do the evaluation quickly. So let me just use a calculator so that I don't waste much of the time. So here what we are going to do, okay, let's do like this. Okay, so say open brackets, so have like 12 we'll say 12 times 2 close brackets, then plus open brackets, then 1 times 4 close brackets plus open brackets, you have 16 times 2 close brackets, then equals, it will be 60. So this one has given us 60, has also no units. So this is how you find these things here. Now let me give you the task now. So this is the task which you are going to perform. So question 1 says find the relative formula masses of the following compounds. So you have A, you have potassium, 2 here sulfate, which is SO4. Then B, you have zinc nitrate like this. Then BEC, you have ammonium aluminium carbonate. Okay, aluminium carbonate will just be like this, I think. Yeah, like this. Then what else? Okay, let me go to question 2 also, which can say determine the relative molecular masses of the following compounds. Okay, so you have A, you have CH4, B, you have like C2H6, then C, you have CO2. Yeah, so these are the questions I've given you for you to answer. Practice makes perfect. The more you practice, the more perfect you become. All right, so this is where we end with this lesson. I hope you have benefited from it. As for now, bye and see you in the next lesson.